Imagine being told that a solar panel could cost less than dinner for two. It sounds ridiculous until you look at what Chinese manufacturers have done to the economics behind it. Because the strange part isn't simply that China can make solar panels cheaply. The strange part is what happens when an entire industrial system becomes optimized to make them cheaper, faster, and at enormous scale. And that creates a much bigger question. If solar keeps getting cheaper, who actually wins, the consumer, the manufacturer, or the country that controls the supply chain? The $8 solar panel in this title should be treated as a dramatic price premise, not a literal verified retail price. Real solar modules contain far more than a single panel's manufacturing cost, and the final price depends on materials, shipping, tariffs, installation, financing, and other equipment. But the underlying phenomenon is very real. China has become the dominant manufacturing center for solar photovoltaic technology. The International Energy Agency says China's share of manufacturing capacity across the major stages of the solar supply chain, including polysilicon, ingots, wafers, cells, and modules, exceeds 80%. And China isn't merely producing the final panel. That's where the story gets interesting. Because if one country simply assembled cheap panels from components made somewhere else, competitors could potentially catch up. But that's not what happened. To understand the real advantage, we have to take the solar panel apart. Not physically, but economically. A finished panel looks simple, but before it reaches a solar farm or a rooftop, a long chain of industrial processes has already happened. Silicon has to be processed. That material becomes polysilicon. Polysilicon becomes an ingot. The ingot becomes wafers. Wafers become solar cells. Cells become modules. And around all of this is another network: glass, aluminum frames, chemicals, machinery, cables, inverters, transportation, engineering, financing, and thousands of specialized suppliers. So when someone asks, why can China make solar so cheaply? The easy answer is China makes things cheaply, but that's not really the answer. The deeper answer is that China built a system in which thousands of economic decisions reinforce each other. And once that system becomes large enough, something unusual happens. Scale itself starts becoming a competitive advantage. Imagine two factories making the same product. One produces a relatively small number of panels. The other produces at enormous volume. The second factory can spread expensive machinery, engineering, research, logistics, and other fixed costs across far more units. Its suppliers also have more customers. Its workers and engineers gain more experience. Its equipment manufacturers specialize further. Its transportation network becomes more efficient. And when all of those improvements happen at the same time, the cost of the final product can keep falling. That's the part many people miss. China's advantage isn't simply one cheap factory, it's the neighborhood around the factory. The supplier, the machinery company, the chemical producer, the glass manufacturer, the logistics provider. The engineering team, the financing network, the next factory, then another one, and another. Over time, the entire ecosystem starts behaving like one enormous machine. The IEA estimates that manufacturing solar PV components in China is currently about 20% cheaper than in the United States, before considering the full range of policy support and trade measures. The agency points to differences in energy, labor, investment, and overhead costs, but also to the broader competitiveness of the industrial ecosystem. And this is where the $8 idea becomes much more important. The real question isn't whether one company can sell one panel for an unbelievably low price. The real question is, what happens when the entire industry keeps pushing the cost curve downward? Because cheap solar creates its own feedback loop. Lower panel costs can make more solar projects financially attractive. More projects create more demand. More demand supports larger factories. Larger factories can improve production efficiency. Improved efficiency can push prices lower, and lower prices can create even more demand. It's a cycle, and once that cycle gets moving, catching up becomes much harder. But there is a problem hiding inside this success. The companies producing the cheapest panels aren't necessarily getting rich. In fact, the opposite can happen. When manufacturers build too much capacity, they begin competing aggressively for market share. Prices fall, margins disappear, factories fight for customers. and eventually the cheapest producer may be under enormous financial pressure too. That sounds like a contradiction. How can an industry become more powerful while its manufacturers struggle? Because the real winner may not be the company selling the panel. The real winner can be the technology itself. If prices fall dramatically, consumers and developers can benefit even when manufacturers suffer. And this is exactly why China's solar story is bigger than China. The world gets cheaper solar technology. China gets enormous manufacturing scale. Other countries get a cheaper path toward renewable electricity. But American manufacturers face a completely different question. How do you compete against an ecosystem that has spent years becoming extremely efficient? This is not as simple as opening a factory in America and putting solar panels on the assembly line. The factory is only one piece. You need suppliers, you need machinery, you need trained workers, you need financing, you need materials, you need customers, you need enough production volume to spread costs. And you need the confidence to invest billions before you know whether the market will still look the same several years later. That's an uncomfortable problem, because an American company could build an excellent solar panel and still struggle to match the economics of a Chinese competitor, not because the American engineers are incapable. Not because American factories can't automate, but because they're entering a race where one competitor already has the entire track built. And here's where the story takes an unexpected turn. You might think the biggest threat is simply cheap Chinese panels entering America, but that isn't the whole story. The bigger issue is what happens when manufacturing leadership begins spreading into other parts of the energy system. Solar panels need inverters, solar projects need electrical equipment, they need storage, they need transmission. They need software, they need installation networks, and some of these supply chains are also highly concentrated. The IEA estimates that China accounted for around 80% of global inverter manufacturing capacity in 2025, while its share of wafer manufacturing was around 95%. Now the story is no longer about one cheap product, it's about infrastructure, and infrastructure is different. If you lose access to a consumer product for a few weeks, that's inconvenient. If your economy becomes dependent on a concentrated supply chain for technologies that will power factories, buildings, transportation, and electricity systems for decades, that's strategic. This is why the United States has been trying to rebuild domestic clean energy manufacturing. The goal isn't simply to make American solar panels more expensive. The goal is to create a domestic industrial base that can survive global shocks and reduce strategic dependence. But there's a difficult trade-off. Protection can help domestic manufacturers. Yet protection can also make products more expensive, and cheap products are exactly what developers want when they're trying to build more solar capacity. So America faces a strange contradiction. The country wants cheaper clean energy, it also wants domestic manufacturing, it wants resilient supply chains, it wants to compete with China, and it wants consumers to pay less. Those goals can support each other. But they can also collide, and that's why the solar industry is such an interesting economic battlefield. Because this isn't simply China versus America, it's a debate about what kind of industrial economy the future should have. Should countries accept the cheapest products available on the global market? Should they pay more to build strategic industries at home? Should governments subsidize manufacturing? Should trade barriers protect domestic producers? Or should consumers simply be allowed to buy the cheapest technology? There is no easy answer, and there's another number that makes this even more complicated. The IEA says solar PV installations exceeded 600 gigawatts globally in 2025, pushing cumulative installed capacity to roughly 2,800 gigawatts. Solar became the world's largest source of installed renewable generation capacity by technology. That means this isn't a small niche anymore. Solar is becoming part of the basic infrastructure of the global economy. So every percentage point of cost reduction can matter. Every improvement in manufacturing efficiency matters. Every supply chain bottleneck matters. And every country trying to build a domestic solar industry is effectively trying to answer the same question. Can we produce this technology cheaply enough to compete? China's answer has been built over years. Investment created factories. Factories created demand for suppliers. Suppliers created specialized expertise. Specialization lowered costs. Lower costs created more demand, and more demand justified even more investment. That feedback loop is incredibly difficult to reproduce overnight, but there is one final twist. China's dominance isn't necessarily permanent. Other countries are already trying to diversify solar manufacturing. The United States is building domestic capacity. India is expanding. Southeast Asia has become an important manufacturing base, and governments increasingly care about supply chain resilience, so the future may not be a world where China produces everything. It may be a world where China remains the cost leader while other countries deliberately accept higher costs to gain greater control over their own supply chains, and that could create an entirely different kind of competition. Because the next battle may not be who can make the cheapest panel. It could be who can make cheap panels without becoming dependent on someone else. That's a much harder question, and it brings us back to that tiny number. $8, whether the exact figure ever represents the true delivered cost of a finished solar system isn't the important part. The important part is what the number represents. A technology once considered expensive is becoming dramatically cheaper. A country that invested heavily in the entire manufacturing chain has gained enormous scale, and companies in other countries are now being forced to rethink what competitiveness actually means. Because when the price of a product falls far enough, the competition changes. You're no longer fighting over luxury customers. You're fighting to become part of the world's basic infrastructure. That's why the solar story isn't really about a cheap panel. It's about what happens when manufacturing scale becomes powerful enough to reshape the economics of energy itself. And if that trend continues, the biggest question won't be whether America can build solar panels. It will be whether America, or any other country, can build an entire industrial ecosystem capable of competing with the one that made those panels so cheap in the first place. Because the future of energy may be decided long before electricity reaches the grid, inside factories, supply chains, and manufacturing systems that most people will never see. And that is the real story behind the $8 solar panel.